I'm Stephen Foskett, the organizer of Tech Field Day, and you're about to see a presentation and discussion with Docker. Around the table we have a dozen and more independent experts in enterprise IT, and they are here to listen, to discuss, and to interact during the presentation. If you'd like to learn more about this event, you can go to techfieldday.com, and if you'd like to see more videos like this, you can go to youtube.com/techfieldday.
So my name is Madhu Venugopal. I've been with Docker for a couple of years now, working on Docker networking, Docker for AWS and Azure, and also leading the CS commercial supported engine project as well. So 20 minutes, I'll try to quickly cover the topics here. So Docker networking, we have a fabric of network features. The base of the Docker networking is the container network model. I'll talk briefly about what that model is. It has built-in IP address management, IPAM solution, of course. We have built-in native multi-host networking using VLAN networking. We have native service discovery and load balancing. And you can replace your existing native solutions like the Mac VLAN, IP VLAN, VXLAN networking using plugins like Cisco's Contiv plugin or VMware's NSX plugin, so on and so forth. And we have multi-platform solution like Linux, Windows, Solaris, so on and so forth. It works on various platforms, not just the apps, also the solutions on the networking fabric. So as Michael covered, Docker is a very, very fast-moving project. So 1 year before, if you look at Docker, it is very different, and now it's completely different now, right? So the Docker has actually migrated from being a container runtime to an actual full-fledged platform for running your distributed applications. So we realized early on, much early, that without networking being part and parcel of the Docker platform, it cannot become a platform. So we invested so much time and effort for the past 1.5 years to beef up a lot of networking features right into Docker. And more importantly, the networking features that Docker provides today doesn't require any additional software that has to be installed. You install Docker, we make use of all the existing Linux kernel features and now Windows kernel features as well to give what that application really wants. As you can see, for the past 1.5 years, we have like 7 releases. We are a really fast-moving project. You can see that the around 1.7 is when the socket plane was acquired, where I was part of. And we started working on libnetwork and started working on the platform called the CNM model in order to make sure that applications are portable, regardless of which networking solution that you want to use in your laptop to the production deployment. Then came the service discovery using simplified H3 host-based service solution. And 1.9 was a big release for us where we introduced the multi-host networking using VLAN Driver. We had the plugins for networking and IPAM. We added the Docker Network UX, which is the big thing, because Docker is where it is today because of simplicity. So prior to Docker, containers were there. It was so complicated to use, but Docker came and changed the game. So we had a similar concept where networking is complex. We all know that. It has various deployment scenarios, various solutions, and our idea is to make it simple. So the UX, Docker Network UX, if you look at it, is as simple as it can get, but you can get the extreme use of networking features like the overlay, VXLAN, Mac VLAN, so on and so forth. And we added the service discovery as part of 1.10 with an embedded DNS. So now the DNS server running as part of the Docker platform and is distributed as well. So if you deploy an application, distributed application in a Docker Swarm, it default uses a DNS. Any DNS request from the application actually is handled by the Docker platform, and hence you can deploy a Docker service, provide an alias, give a name, and the application can access the name, and automatically it routes the traffic based on your service deployment. So it's built in. Then we added the load balancer solution using initially with DNS round robin. We support multiple A records, so you can have a service with multiple tasks, and each task will be round robin using the DNS A records. But 1.12 came and changed the game actually. So 1.12 is a big feature release, as we all spoke about here. So it has built-in swarm mode. then we added the virtual IP based load balancing. So we use the IPVS load balancing module of Linux, which is pretty awesome. If you haven't tried it, try it out. Linux kernel has this IPVS solution where you can actually have a virtual IP to physical IP backing. So we can use that as a layer 4 load balancing mechanism. And we have an encrypted, by default, encrypted control plane and data plane. So now your VXLAN tunnels are fully encrypted between your nodes. So when you write an application, you can be guaranteed that every packet has been encrypted from end to end within your cluster. And we have a cool feature called routing mesh, which I'll talk about in the detailed slide. The idea of routing mesh is that if you deploy an application using swarm mode in a cloud, you actually don't even need an ELB for load balancing. You can just hit any of the nodes and you'll get load balance to the appropriate place where it has to go to. So routing mesh is a really powerful feature which I will explain later. And as of 1.12, we also added the new driver called the Mac VLAN driver. So the idea is that networking, as I said, is complicated. It has various deployment scenarios where users need different configuration requirements. So Mac VLAN is one of the requirements that we heard from many enterprise users, where they would like to have their underlay VLANs plumbed right inside the host and the VLAN to be terminated right inside the container, right? So we added that functionality where the Mac VLAN driver, again, Linux kernel provides that. So using that, we can actually take your underlay VLANs and plumb it to the host, and you can place your containers on the VLANs where the same VLAN, you can have other containers, other VMs running or other physical servers running there. You can plumb them in the same VLAN and run DHCP server and assign IP addresses, so on and so forth, to a container. So that's the power of Mac VLAN driver as well.
So, okay, back up. I'm plumbing .1Q tag up.
Right, to the host.
And so when that packet arrives at the host, you're actually looking at the frame,
right,
pulling out the .1Q tag,
that's right.
and
assign based on the VLAN, we know which network it belongs to, and assign and take the traffic. Of course, the Mac VLAN driver will decapsulate and look at the MAC address and then deliver it to the right container, essentially. It's a very powerful feature. If you are not an overlay geek, if you want an underlay integration, this is one for you. This is highly performant. It just has no overhead at all. It's not even a bridge. There's not even a bridge there, right? So if you look at the typical networking solutions today in container world, you will see a bridge there which will do either a NATing, port mapping, so on and so forth, or an VXLAN driver which does an overlay encapsulation. While Mac VLAN is really like native performance on your kernel, where traffic comes in, hit the driver, and goes out with the VLAN tags configured appropriately.
And we've got that in 1.12.
1.12, yeah.
Is there some magic you have to do to enable that? Because if I stand up container
there's no magic.
today, I don't.
There's no magic. Just do Docker network create -d Mac VLAN. You have Mac VLAN.
Okay. You just have to instantiate it. You got to create a network that's going to use that feature.
Right. That's why the UX is important. So if you look at the Docker network, the command is exactly the same for any driver that you want to use. If you want to use an overlay driver, just do Docker network create -d overlay. If you want to use a Mac VLAN driver, just say Docker network create -d Mac VLAN and give a name, and use that name when you run a container. Just say Docker run -net, give the name of your network, and that will use the Mac VLAN driver now.
And is it sending out tag packets then?
Yep.
To that container?
Yep.
Okay. So I've got to have something on the other end that can.
Yes. If you have an Arista switch or whatever switch, you configure them appropriately with the tagged interface, like Docker, and then you just.
And if I'm talking to a vSwitch on top because I'm running my containers in hypervisor, then I've got to consider that. I've got tagged frames coming out and I deal with it.
Exactly. So it's depending on the deployment itself. If your deployment is container to VM to a top of the switch, you can do it appropriately. Or if it is a bare metal server connected to a top of the switch, just do it that way. So this one works. We validated with multiple vendors. Actually, so it just works great. So it's part of 1.12. It's a good feature. So 1.13, which we are working on now, not released yet, which is we are trying to bring Windows feature parity in this one. So we are working with Microsoft team, and now we have actually the code is committed now. It supports swarm mode. We support VXLAN driver in Windows. Service discovery is built in. Load balancer using DNS round robin. So I'm very happy that we have parity on the swarm mode features on Windows as well now. So, all right. So this is the feature set that we have now, and how we have come from one for the past 1.5 years, we've been really busy getting these features in. So why it is important that without these features in place, we cannot have a production deployment of Docker containers in a real production scenario. So all this actually began with the design philosophy of users being the number one for us, for Docker. So users are application developers and network operators. So when application developers take a look at Docker as a platform, they should not worry about VXLAN or VLAN or underlay or overlay or any of those issues. They should not worry about it at all, right? They take a compose file, they deploy it in Docker Swarm mode, and things should just work for them across the cluster. They should not worry about how a packet goes from A to B, and they should not worry about configuring service discovery. They should not worry about configuring DNS servers. They should not worry about how to configure load balancers. So that's the fundamental philosophy that we begin with, and hence, in order to make the life of developers simpler, we added all these functionalities as you saw, and to me, the culmination of that is the Docker 112, where all the features came to fruit, and then we were able to release this product with users first philosophy right there. And operators are another important customers for Docker, so that's why we started giving these drivers, various drivers, which operators can actually start playing with based on their deployments. So now we have MAC VLAN drivers, IP VLAN drivers. We have configurability. Every network can be configured for different subnets and different VLANs. So operators can come and configure it based on their deployment scenarios, while the compose file need not change a bit. So the idea is developers can develop their application using compose, test it in the laptop using VirtualBox, using overlay network, things just work. Push this compose file to the operator, and this is where compose and DAB comes in. DAB is an operator-specific format where operator can actually define different drivers they want to run in their production network, and things just work. That's the idea. And application portability is key. So in order to get proper application portability, network should be portable, and that's where the CNM comes in, which I will cover in the next slide. And flexibility is paramount for operators, and hence it's pluggable. So we have batteries included, like the drivers that I explained now, overlay, MAC VLAN, while operators can actually plug in their own favorite plugins, like Cisco shop or a Arista shop or a VMware shop. They can use their plugins and make it work. So all this, the reason, if you look at it from feature standpoint, it's a spread of features, but none of them is possible without a simpler model that we came up with. So that's one of the fundamental design that we started working on. It's called the CNM, where in a simplistic view, if you look at it, we have endpoints, network, and sandboxes. Sandbox is the container, endpoint is the network interface, a network is the thing which is a virtual entity which connects containers to containers, containers to VLANs, containers to VMs, so on and so forth. So and what abstracts the network are these drivers and plugins. So a different plugin can think about network as an overlay network or an underlay network or a MAC VLAN network that is abstracted out by the plugins, which applications don't really care about. So this is the model that we started with, which helped us move really rapidly fast with all the features that we have now. So I'll quickly go over various use cases where how Docker is deployed on various use cases, so that you understand why we have different drivers, different deployment needs, so forth. So the first use case is the bridge network, Docker 0. This is the very most popular, prior to me joining Docker, prior to anybody looking at Docker as a thing like 2 years back, Docker 0 is the popular one. When you do Docker run a container, we take the container, attach it to this Docker 0 bridge, and that bridge can be attached to the ETH0 and then it goes to the double-stack switch, right? So as you can see here, the most important thing of Docker 0 bridge is all the containers gets their own IP addresses here. It's private space, and then we have an IP tables and NAT and port mapping is done here. So when the packet actually goes out, it goes out as a native packet of this host. So if you capture the packet here, you will not know whether the traffic is coming from container 1, container 2, or container 3, because it's natted and port mapped to be the IP address of the ETH0. So think about the container as a process running in your host. when the process sends the packet out, it's going to be an IP address of the ETH0 itself, right?
So if we're not great believers and faithful adherents to NAT and don't like it at all in any way, shape, or form,
right.
Can we have multiple Docker bridges and just put them natively on the networks?
Yeah, yes. So I'm going to talk about that. So this is the number one use case that is way back before 1.6, right? So this is the fundamental one which is everybody uses today. And then we have user-defined bridge. So this is where you can ignore the Docker 0, you can create your own bridge. Docker network create, as I said, -d bridge. This is your bridge, and start running your network thing, right? So when you do this by default, you're going to again get the NATing and port mapping by default. But what you could do is you can actually plumb your interface directly like this, right? So if you don't need a NATing and port mapping, you can do that as well. You can just attach your physical interface to the bridge, and there you go. So you don't need NATing and port mapping. Take your physical interface, attach to the user-created bridge, and you have the access to the network directly. Okay. This is the third way to deploy your solution. As I said, if it doesn't like NATing and port mapping, this is what it is. Just go with this one. But another way to do, I'll ignore this one and go here. Other way is if you don't like bridge at all. So bridges also add some latency for your packets. If you don't like bridge, if you want to do the native performance, Mac VLAN is there for you. So this is Mac VLAN driver.
How much latency for if you keep it in the bridge?
It's negligible. So
Microseconds.
Nanoseconds. It's negligible really. Just that if you want the best performance, then this is what it is. So bridge is not even in the way, right? This is the Mac VLAN driver, as I explained. So as you can see, if you want to use it in your laptop, you can do it. Just say Docker network create -d Mac VLAN, and if you want to know which subnet you belong to on your underlay, provide the subnet, and that's it pretty much. And provide the parent interface. You want ETH0.10. So in this case, the Linux terminology is if you say ETH0.10, the 10 is the VLAN, ETH0 is the parent interface, and you start plumbing things out, right? Pretty much that's it. So you create a Mac VLAN network and do a Docker run on this name, and now you are actually part of the network using the VLAN 10 right there, right? So this is another way to do without NATing and port mapping at all. And there you go. And of course, the entirely another way, the SDN way of doing things is overlay. Because if you look at the Mac VLAN all depends on the underlay mechanisms where if you configure a VLAN, you want to make sure that your top of the rack switch is also configured the same VLAN. If not, things are not going to work, right? So there's a network operator thing there where operators must configure the switches and routers in order for it to work. But overlay is the true portable solution where you write an application, overlay kind of abstracts your underlay completely, and your application just works anywhere. Laptop, your cloud, your data center, doesn't matter, right? Yeah.
Well, I want to challenge that a little bit.
Yeah, let's talk about that.
Mike?
Yeah. Mike?
On the floor.
Make sure you turn it on.
You turn it on.
It's got a fresh battery. So what I'm seeing is, is VXLAN either in the Cisco or the NSX setting where people are starting to think about setting it up between data centers.
Uh-huh.
And that makes it very easy to move virtual machines or containers between data centers.
Right.
The challenge I see is that virtualization necessarily imposes some overhead.
It does.
CPU and memory are relatively cheap, and so the overhead doesn't hurt. With networking, bandwidth between data centers is a scarce resource, and there's a different impact there.
True. So, see, it actually depends on various factors here. So VXLAN itself doesn't add a lot of. So let's put it this way: the VXLAN, if you look at the VXLAN header, that's going to add a little bit extra bandwidth for you, right? But that is negligible compared to the actual benefits you're going to get out of it, right?
Well, the overhead is both bandwidth. What I'm seeing, because I've had to troubleshoot this for some developers, is things like, oh, let's stick a component over in the other data center. Well, they don't realize the application does a lot of ping-ponging back and forth, multiplying the latency by 1,000, and all of a sudden it's slow, and it's oh, the network's fault. But really, it's the developer didn't understand what latency did to them. And the other consequence of the ping-ponging or tromboning type behavior that occurs,
Got it.
where you're going between stuff that's back and forth between the data centers as you work through the tiers of the application, and that makes it slow.
Right. So the problem of tromboning, right? The problem of ping pong on the data path is not there in Docker at all. In Docker networking is very different compared to the other way of doing things, right? Because we don't have gateway. So there's no gateway, right? So if you have a gateway, then you are right. Then you have to actually do a tromboning. You have to go to one data center, come back here, and things like that. Here we are very clear about our design. So in the Docker networking overlay design, overlay is purely east-west. We don't do edge-based routing using overlay. So the edge routing is done on individual hosts, and we don't have any gateways for overlay. So the traffic that goes on the overlay is purely east-west application traffic. If you want to do any north-south traffic, it's not using overlay at all. So what we have is a fully distributed solution, as you can see here. Every container is attached to two networks automatically. If you're running in overlay network, your container is attached to two networks automatically. One is the overlay network for east-west traffic within your cluster, and north-south traffic is completely using the bridge network here, right? So what benefit you get out of this one is, if you look at the traffic paradigm, right? 80% of the traffic, as you know, 80%, 85%, 90% of traffic is east-west, right? And the north-south is really negligible. So the way we do today is the routing mesh, which we discussed, right? Routing mesh is where the north-south comes in. East-west, since we don't have any requirement for a gateway to reach out, we don't have a problem of tromboning at all. It's completely east-west. So every requirement for one container to talk to another container is one hop away. It's never a two hop. We don't have two hop problem at all.
Well, I'm thinking of distance between data centers and east-west between data centers is where I'm seeing the problem. So it's no worse with Docker than with any other platform.
Exactly, right.
The challenge I see coming from the networking side is that it seems, I've got a joke about this, that I've run into developers where it reminds me of Charlie Brown. We start talking networking and latency, and I think what the person's hearing is blah, 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 blah. And so that's what I see coming is it's facilitating extending VXLAN between data centers, extending layer 2 between data centers. And the challenge with that is it makes it easy for people to do dumb things. And that's
true.
not your problem.
That's true. It's well said there. So it's not just VXLAN is a data plane thing. If you screw up on control plane, then VXLAN is of no use for you, right? So VXLAN itself is not the culprit here. If the control plane is really bad, you can really screw things up. So the way that, as I said, the way we have done it is a bit different, where we know we don't have a lot of features in the VXLAN, but like gateway, because we purposefully didn't want to do the gateway because of the same problem that we explained now. Anyways, I'm 6:30 already, so I just have to move faster. So in 1.12, as I said, we added a lot of good features. I'll skip everything and then go to the important ones, like this one. So the control plane, as I said, it's an important feature functionality. We don't use BGP, we use gossip-based mechanism. And the gossip is fully secured end-to-end. So every network gets its own gossip scheme. So it's encrypted, and man in the middle cannot come and just spoof the data to change the routes. And we use the gossip for route states, plug information, service discovery, so on and so forth. And as I said, this data plane is secured as well, so we use the kernel's IPsec modules for encrypting your VXLAN tunnels. So data is encrypted from day one. Service discovery is built in, so we have an embedded DNS as I explained. So containers get a DNS resolver, and the DNS resolution happens on the Docker engine. And if Docker engine couldn't resolve it, then we will send it out to the external DNS server. And I'm being given the finger, so I need to the finger, right? Finger like this.
said no.
Yeah. So All right, I'm done. In two more slides. So load balancer, we have built a load balancer with VIP and DNS RR. So yeah, it's great. That's all I can say here. Routing mesh is load balancer, but for external, for north south. So the idea is the user need not worry about where the container service is actually running. The traffic can hit any of the nodes in the cluster. The routing mesh will ensure the traffic is redirected to the right place appropriately. Right? That's the routing mesh. It's a very powerful feature. Many users actually love this feature and start deploying DDC for this one. Actually, it's a cool feature. And yeah, so there's a few more things. And if you want to geek out with deep dive, I have a lot more deep dives here, and we can talk a lot about this one. So that's it. Thank you very much.
Thank you, Madhu.
Thank you.
Thank you.
Thank you.
Yeah.